Okay, let's start with number 18. This section wants us to solve either by factoring or by taking square roots. So if a problem has an x squared and an x in it, then I'm going to try to solve by factoring. If the problem has no x, no linear term, then I'm going to do the square root method. So looking at number 18, I see an x squared, I see a constant, but there's no x in the problem, no just linear term. So I'm actually going to solve this by the square root method. So my goal is to get x squared by itself, so I have to move the 4 and I have to move the minus 9. So first I'm going to get rid of the minus 9 by adding 9 to both sides. When I do that, the 4x squared will drop down, and then 0 plus 9 is 9. Okay, I'm still trying to get this x squared by itself, so now to get rid of the 4, I'm going to divide, and then x squared is by itself. If I could reduce 9 over 4 or divide it out evenly, I would do that, but I can't. So I'm just going to leave it 9 over 4. And then in order to make a squared go away, I'm going to square root both sides. Whenever you square root something, you get both a positive and a negative answer. And then the square root over the whole fraction means the square root of the numerator over the square root of the denominator. So the square root of 9 is 3, and the square root of 4 is 2. And that is my answer. So I have a negative 3/2 for an answer and a positive 3/2 for an answer. So if you saw that in a set, it'd be a negative 3/2 and a comma, positive 3/2. And you could see your answer recorded like that. Now, it is possible that I could have factored this problem, just to talk about that for a second. When I spot this problem right away, I notice that this is a difference of squares. So remember, when you have a difference of squares, that's when you have the two sets of parentheses, one with the plus and one with the minus. The square root of 4x squared is 2x, and the square root of 9 is 3. So then I could set both of these equations equal to 0 and solve them. Well, if I set 2x plus 3 equal to 0, I would get negative 3 over 2, because I would subtract the 3 and then divide by 2. And if I set this equal to 0 and solve, I'd get a positive 3/2, because first I would add the 3 and divide by 2. Either way, I get the same answer. So me personally, if there's no x, if there's no linear term, I'm going to do the square root method. But you're welcome to factor it if you so desire. Okay, 19. This one's a little different than some that we saw in the lesson when we were doing the square root method. But I am going to solve this by taking square roots because of the squared here. Now, if there was something else on the side with this, I would have to move it. But since there's not, I'm ready to get rid of the squared. So to do that, I square root both sides. Anytime I square root both sides, I am going to have a positive and a negative answer. And what is the square root of 49? Just a 7. Okay, on this side, I have 2x minus 5s. Well, when you square root that, you only have 1 left. Basically, the squared and the square root, they undo each other. So all I'm left with is what's in parentheses. So now to get x by itself, I just have to add 5 to both sides. So when you do that, you're adding 5 to the positive 7, and you're adding 5 to the negative 7. So let's start with the positive 7. Positive 7 plus 5 is 12, and negative 7 plus 5 is negative 2. And there's your two answers. Okay, number 20. Since I see an x squared and an x, I'm definitely going to factor this. So remember, when you factor, one side does have to say equals 0 before you begin. So I'm going to move this minus x by adding x. So I'm going to have the 4x squared. Since I'm adding x, it's going to say plus x, and then I recopy the minus 3. So left-hand side, it's got to be in order. X squared, x, constant. Okay, at this point, I'm going to see if I can factor. So first I look to see if I have a GCF. I do not. Then I look to see if I have 2 terms or 3, and I've got 3. So I'm going to do a times c rooftop. So a times c gives me how much? Negative 12. I want the numbers to add to be the guy in the middle, which is a 1. You just didn't see it there. So what two numbers multiply to be negative 12 that add to be a positive 1? 4, and negative 3. Okay, I can't shortcut because it's not a 1 in front, so I recopy this first term. Instead of using the middle term, I use these two. So I'm going to use a positive 4x.
Teachers, just a reminder, insurance and benefits sign-offs is in the library, distance learning lab.
A negative 3x.
Letters N through Z.
And then I'm going to bring down the minus 3.
This morning. And if you did not get in yesterday, you need to make sure you get done today. Thank you.
Sorry about that interruption. Okay, looking for the GCF out of the front bunch. The greatest thing that goes into both of those is a 4x. 4x times what gives it back? And that would be x plus 1. The GCF out of the back is a 3. This is where I get a copy. Whatever is here has to go here. They have to look exactly the same, so that's an x plus 1. And then what kind of 3 do you think this needs to be? Negative. That way negative 3 times x makes the negative 3x up here. Negative 3 times 1 makes the negative 3 up here. Okay, so then I take what's in this set of parentheses, I write it one time. Then I take what's left over, which is 4x minus 3, and I write it one time. And then I'm going to drop down my equal 0. So I'm done factoring, I just now need to solve. So first I'm going to set x plus 1 equal to 0. And what would we get if we set x plus 1 equal to 0? Negative 1. You would subtract 1 from both sides and you'd get a negative 1. Okay, next I'm going to set my other factor equal to 0, so I'm going to set 4x minus 3 equal to 0. And what would we get if we solved that equation? A positive 3/4. You would add 3 to both sides and then you would divide by 4, so that would give you a positive 3/4. And those are our two answers. Okay, moving over to 21. Since this problem has no x at all, I'm going to do the square root method. So my goal is to get Mr. X squared by himself. So we have to move the 2, we have to move the minus 80. So I'm going to move the subtraction first by adding. And then the 2x squared drops, the equals drops. 0 plus 80 makes 80. Still trying to get Mr. X squared by himself. So how do we get rid of the 2? We divide. X squared drops. How much is 80 divided by 2? 40. And then to move the squared, I'm going to square root. Remember, whenever you square root something, you have both a positive and a negative answer. Now this time, I can't take the square root of 40 and get something nice and pretty. So I'm going to break him down. I want to know what largest perfect square goes into him and how many times. And the largest perfect square that goes into him is 4, and it goes into it 10 times. And then, what is the square root of 4? 2. You can't take the square root of 10, so that recopies. And so my two answers are a negative 2 square root of 10 and a positive 2 square root of 10. Okay, that was the factoring and square root section. Not so bad. All right, this next section, we are solving with the quadratic formula. This is the king of all formulas for quadratics. It solves all the different quadratics that we have. Okay, first thing we're going to do is we're going to find our discriminant. I do have to make sure my equation says equals 0 and that the left side's in order, x squared, x constant, so I'm all good there. I am going to identify my a, my b, and my c, though, before I begin. So my a is 2, because that's in front of the x squared. My b is 4, because that's in front of the x. And my c is negative 16, because that's the constant. Okay, the discriminant is the expression b squared minus 4ac. So I'm going to slap down parentheses with the squared on the outside. Then I'm going to plug in the b, and we said the b was 4. Then I'm going to recopy the minus 4. Where the a is, I'm going to build parentheses, and I'm going to put in my a, which is a 2. Where the c is, I'm going to build parentheses, and I'm going to put in my c, which is negative 16. And then I'm going to grab my handy-dandy calculator, and I'm going to type it in just like I wrote it on my paper. So parentheses 4, close the parentheses squared, minus 4 times 2 times negative 16. And that makes 144. Okay, we learned the other day that if our discriminant is bigger than 0, I'm going to try to go back and show you. if our discriminant is bigger than 0, and 144 is definitely bigger than 0, then we have two real solutions. Okay, so that's the type of solutions I have. We have two real. And now we're going to find them with the quadratic formula. So, x equals the opposite of b. What's the opposite of b? -4. Plus or minus square root. This is b squared minus 4ac, but we already found it to be 144. All over 2a. And what's 2 times our a? 4. Okay, at this point, you're trying to break down the square root of 144. And he's a perfect square, so it's going to come out nice and sweet. What's the square root of 144? A 12. A clean, pretty little 12. Not square root of 12, but just a 12. Okay, because there's no radicals in here at all, I can get two nice answers. One using the plus and one using the minus. So let's go plus first. What's -4 plus 12? 8. And 8 divided by 4? 2. So there's one answer. Okay, the other answer is going to come from using the minus. So what is, let me see if I can cover that up. What's -4 minus 12? -16 divided by 4? -4. And there's our two answers using the quadratic formula. Fun, right? Okay, number 23. So first I look to see if it says equals 0. It does not. So to move the -2, I'm going to have to add it. So the left side's now going to say x squared minus 6x plus 2 equals 0. And then I'm going to identify my a, my b, and my c. Which one's the a? 1, because that's what's in front of the x squared. Which one's the b? -6, because that's what's in front of the x. And which one's the c? +2. Okay, now we're going to calculate our discriminant. That's the b squared minus 4ac. So remember, we're going to slap down our parentheses with the squared on the outside. And then which one's the b? -6. I recopy the -4. Parentheses, plug in the a, which is a 1. Parentheses, plug in the c, which is a 2. And then I'm going to put that in my calculator. So in the calculator, I'm going to go parentheses, -6, close it, square it, -4 times 1 times 2. And I get 28. Well, once again, since my discriminant is bigger than 0, I am going to have two real solutions, just like the last time. As long as the discriminant is bigger than 0, there's two real solutions. And now we're going to find them using the quadratic formula. So x equals the opposite of b. What's the opposite of b? A +6. Plus or minus square root. This one's b squared minus 4ac. Well, we just found it to be 28. All over 2a. And what's 2 times our a? 2. Okay. At this point, this is where we try to break down the square root. But unfortunately, we can't break it down like we did this one. This one was a perfect square, so it came out nice and pretty. You can't take the square root of 28 and get anything nice and sweet, so we have to do what perfect square goes into them and how many times. And we want the largest perfect square. So it's a 4, and 4 goes in there 7 times. And then what's the square root of 4? 2. You can't take the square root of 7, so that recopies. So I'm going to replace the square root of 28 with 2 square root of 7. So I'm going to recopy the 6, the plus minus. I'm going to replace this with 2 square root of 7. And I'm going to recopy the all over 2. At this point, I just look to see if I can reduce it. So remember, if something's attached to a plus or minus, you have to be able to reduce both pieces in order to reduce. And I can reduce 6 over 2, and I can reduce 2 over 2. So I can reduce this down. So what can I divide all those by? 2. What's 6 divided by 2? 3, plus minus. What's 2 divided by 2? 1, but I don't have to write it. And what's 2 divided by 2? 1, but I don't have to put that either. So there's my answer. And what that really means is we have a 3 plus square root of 7, and we have a 3 minus square root of 7. It is two answers. It's just written smushed together with the plus minus. Okay, moving on. 24. We're ready to go. It says equal 0. The left side's in order. So what's the A? 1. What's the B? -2. What's the C? +5. Okay, discriminant time. B squared minus 4AC. So where the B is, I slap down the parentheses with the squared on the outside. What's our B? -2. Recopy -4. Slap down parentheses. What's the A? 1. Slap down parentheses. What's the C? 5. And now it's calculator time. So in the calculator, we type it in. Parentheses, -2, close it, square it, -4, parentheses 1, parentheses 5. And we get a -16. Okay. Let's flip back and see what that means. We got a -16 for our discriminant. That is a number that's smaller than 0. So that means we have no real solutions. We have what are called imaginary solutions, which have the letter I in them, but you don't learn about those until Algebra 2. So we're going to write down that there's no real solution. And we're going to stop there because that's the answer to our problem. There's no real solutions. You won't solve that until Algebra 2. Yay! Okay, one more on this page. So I look to see if it says equal 0. It does not. So how am I going to move that pesky little 14x? I'm going to subtract it. So it's going to say 2x squared minus 14x, because I'm subtracting it, and then recopy plus 23. Remember, this side has to be in order. X squared, x constant. Okay, which one's the A? 2. Which one's the B? -14. Which one's the C? 23. Okay, discriminant time. B squared minus 4AC. So this time I'm not going to type it, or I'm not going to write it. I'm just going to type it. Parentheses, -14, close it, square it. -4, parentheses, type in the A, parentheses, type in the C. And we get a 12. Okay, since the discriminant is bigger than 0, we're going to have two real solutions, which is what the top section looked like. And so now we're going to find them with our handy-dandy quadratic formula. So it starts off, x equals the opposite of b. What's the opposite of b? A +14. Plus or minus square root. This is b squared minus 4ac, which is 12, all over 2a. And what's 2 times a? 4. Okay, our work now is in trying to break down that square root. So you can't take the square root of 12 and get anything pretty. So I need to know what's the largest perfect square that goes into him and how many times. And 4 goes into him 3 times. Well, what's the square root of 4? 2. You can't take the square root of 3, so that recopies. Okay, so I'm going to replace this with this. So I'm going to recopy the equals 14, the plus minus, replacing square root of 12 with 2 square root of 3, and I'm recopying the all over 4. Then I look to see if I can reduce both pieces. I can. So what can you actually divide all three of those numbers by? 2. So what's 14 divided by 2? 7. What's 2 divided by 2? 1, which I don't have to write, but I can if I want to. And what's 4 divided by 2? 2. And there's our two answers. And that's the quadratic formula. Okay, the next section we're going to see is back here where we complete the square and then we get a solve by the method of our choice. And so I'm going to make a separate video for that. I'm going to stop this one right here for right now.